0.3 divided by 6 is 0.05. So if it's under load,
specific solutions, solving problems so you don't have to. Well, these are our problems, but we'll solve yours too.
today's quest was gonna be... excuse me. Is gonna be to rebuild this thing.
Oh, I love that turtle.
Turtle?
Little printed turtle, flying turtle.
Oh yeah! This, I believe, has to be pulled off because it looks like a pressed fit and I can't find anything in the back. And you can see from my past attempts I've damaged the thread. So that means I need to make a gear puller thing for this. So the first step in this quest is to identify this thread. 7 peaks, which means 6 threads, and from top to top is 0.3 inches, and 0.3 divided by 6 is 0.05, and 1 divided by 0.05 is 20, so it's 20 threads per inch. And then crown to crown, it's 1.244 inches in the lovely Machinery's Handbook. So we know it's 20 TPI, 1.248, yep, that would do it. Now the more astute among you might ask, why not just take the ring from the other side? But yeah, that's a big old nope. Alright, thank you very much.
You're welcome.
Bye-bye. All of the internal threading tools I've seen have a round shank offset with the threading tool ground onto the end, because I need to grind an off-center shaft in tool steel. Huh. Okay. So this is the shape I'm going to try to grind in. I don't know. Look at that. That's basically what I expected. Seems to have worked. That looks like a threading tool. It almost feels like you could... Oh, I guess you can. Thanks for the tip, Tony. This might be going a little fast. Setup isn't great, but it's gonna work. Moment of truth. Sure seems like it's on there real good. Cool. Well, it's not doing what I'd expect, so I'm gonna stop and think before I force it. So Handy Dad pointed out that there was a little pin back here that I hadn't noticed before. We tapped it out and, well, hey, the whole thing just pops out and it doesn't need to be pulled at all. Good! There's a little collar right here which rests on top of this fork right there. So if I shove this collar up onto the fork, I think it'll develop more preload enough to actually drive this thing. So it's like engaged. If you do this, it doesn't disengage. But if you like fuss with it, it'll disengage. The fix was to put just a little bit of WD-40 on this coupler right here. So I'm gonna see if I can explain just what's going on here. So this has a bevel gear that connects to a bevel gear right here. This bevel gear has an engagement plate that mates with another engagement plate with a spring, a little lever arm, a captive collar, a shaft, a sliding collar with a pin in it. So when this lever turns, it forces the arm up, which engages these two plates together, which means that this locks in place. When this lever disengages, hypothetically the arm falls and these engagement plates separate and the arm can turn. So while this was all gummed up, it just wouldn't slide up to engage because it was stuck in the down position. But now, the only thing that allows it to disengage is gravity. So if it's under load and you disengage it, it's not gonna disengage very easily. So somehow we need to spring load that arm again, but I mean, I don't know, it works. Just a little WD-40 in the right spot. So I could have fixed it without even taking it apart or machining or anything. But isn't that the way it goes? You spend all the time figuring out what you don't know and then the fix turns out to be easy. But either way, yeah man. Hey, remember that. Signing off. This is Specific Solutions.